Yeah, I'm very impressed that this many people have turned up to hear about MXF before 9 o'clock in the morning. It's quite impressive. I'm from Metaglue. We're a software company that delivers tools for MXF. The company was started back in 2001 by myself and Oliver Morgan, who some of you may know, who was one of the two guys really that wrote the original MXF spec. And since then, we've been doing MXF tools, software development, and as our name suggests, all sorts of ways of gluing together metadata systems. So that's the background to Metaglue. So this is what we're going to do today. I'm going to do a bit of a recap on MXF. It's always a bit of a problem talking to a group like this because you never know quite how far people are with MXF and how much they know about it. So I apologize to those of you that know MXF like the back of your hand, but I hope that bit's useful to you. And then I'm going to talk a bit about the way that the MXF standard has been approached and give you some flavour about why it is as it is, which makes it much easier to understand how you build systems if you understand the underlying philosophy. And then I'll just talk very briefly about what you want to look at when you've got problems with MXF systems not working together. And hopefully that will give you enough background that for the rest of the time you'll be able to think more clearly about how you achieve MXF delivery. The trigger for this breakfast, of course, being the digital delivery project, AS11. I'll unpack the AS11 phrase in a bit later, but the AS11 standard for delivering to Channel 4 ITV and the BBC. It's worth pointing out to start with that AF and MXF are the different sides of the same coin. You may be familiar with AF if you've been using your Avid. That came along following OMF. AF is really OMF from Avid version 3, but made public. There's an open source SDK that everybody uses. But AAF was too complicated for just doing simple delivery, either out of a camera or to a broadcaster. And one of its big downsides was that you needed to have the whole file before you could start to read it. Whereas an MXF file, you can read and write at the same time. And that was one of the key drivers. There were a number of other drivers. As I say, a lot of the uses for video file transfer was didn't need a lot of the features of the AAF SDK, so the AAF standard. So MXF came along. It's got exactly the same data structures as AAF and exactly the same philosophy underlying it, but simpler and a file layout that allows you to read and write at the same time and stream generally. Worth just reminding ourselves what MXF is and what it isn't. MXF is a wrapper. So the whole philosophy behind AF and MXF is to have a standard wrapper that you can go into that's got enough facilities for broadcast use that will tell you everything you need to know about the file without necessarily being able to play back the pictures, subtitles, the audio. But at least if you look at the file, you've got enough information there to know what it is and decode the metadata, see what type of video you've got, maybe what the program number is, all sorts of information without actually having to read the file. It's also really designed as a format for moving between systems, and although many systems do use it internally, that wasn't its original design purpose. Avid particularly use MXF internally. And also, worth bearing in mind, it's completely public, it's well specified. It hits a lot of criticism because it's too complicated. And I think in a way that's, the fact that it's complicated is fair criticism. The fact that it's too complicated is unfair. It is a complicated domain. It's a complicated thing that's been trying to be done to do a file standard that works in such a wide range of applications from camera to delivery. It's complicated stuff. If it wasn't complicated, we wouldn't be in business. And by we, I mean television and post-production generally. not Metaglue in particular. MXF is not a universal exchange format, so you must not expect that any MXF file can be read by any MXF decoder. As I say, you should be able to read and see why you can't read it, but you can't expect that every file will be read by every decoder, and not least for the reason that you can put any video format you like in there, and no more than you would expect an MPEG decoder to decode DV. What should you expect a DV application to decode something that's got MPEG video inside it? And it's also not really designed for work in progress. It holds large video, but it won't hold wide timelines. That's where AAF comes in. So you use AAF for transfer between your workstations. You use MXF for transfer between processes. So seeing as the sort of thrust of today is on delivery for end use by file, it's just worth stepping back for a second and thinking about the requirements for file delivery for transmission file delivery. Obviously, the quality has to be high enough for the transmission channel, and this is not as obvious as it might appear. The Americans, for example, will accept a much lower quality than the UK broadcasters, and that's not particularly because the Americans don't worry about what they deliver to the front room. They worry very much. It's because the UK broadcasters do a lot more processing before it goes out, in terms of making trails and using the material for other purposes, so they need to be able to edit it afterwards. So you'll see American delivery standards that are different, lower bit rates. And also the Americans as moving material right across the country over satellite to all their member stations, whereas that's not the way we work in the UK. The quality needs to be good enough, sort of goes without saying, but worth thinking about. It needs to be compatible with the automation systems. There's absolutely no point in doing file delivery if you then have to manually type in a whole load of information. The whole point of doing file delivery is that both the deliverer and the receiver are able to save in their processes and make the whole thing simpler and cheaper. You've got to have enough metadata in the file that an automation system can absorb it and know that they've got the right stuff. The other side of the same coin, you've got to know that you've had the right thing delivered. I remember from my early days of transmitting the wrong program, and really that's not a good thing to do. It's got to be reliable. You've got to have a system that you can duplicate the file, that you, once you have duplicated, you know that you do have the same material. You've got to be able to check it, and once you have checked it, know that it hasn't changed since you checked it. That's relatively easy with a tape, although people can check a tape and then drop it in a puddle. You must be able to tell that the file is the same as the one that you checked. And last and least, if it doesn't save money and or time, then there's no point in going down this line just for the sheer joy of the technology. So let's now park those thoughts and just dive into the way that MXF thinks about holding media. We start off with a media object, and the media object has several tracks in it. I'll come and develop in a minute as to how many media objects we may have in a file. But firstly, the first thing to be clear about is that there's a unique ID, 16-byte number that's completely unique, and you can be as near as damn it sure that when you look at that ID, that is the one, and that you're not going to have another number in your system that's the same. If you do have another number in your system that's the same, then a lot of asset management systems will come to the wrong conclusion. In each media object, there's a number of slots. Video and audio, you can have as many as you like in an MXF file. You can have as many timecode tracks as you like, and then as many descriptive metadata tracks as you like. A descriptive metadata track, which is really the bit of magic that makes MXF work well, can either be something that describes the whole program, a program number, for example, or it can be something that defines something that happens at this point, which, for example, could be this is where the commercial break goes in. You can then divide the track up into slots, so you can have, for example, different sections for program delivery between commercial breaks, and have one audio and then another piece of audio down a track, just like you would on an edit station timeline. And then each track can link to another media object. So again, like you have on an Avid or any other workstation, you have the master timeline, and then each object on the master timeline will refer back to a file that actually holds the media. So the data architecture is very natural in MXF. It's the way that we work. So here we have the way that they might link together. We have the master mob, which is effectively the timeline in front of you on your workstation. That refers back to a media object that describes what's in the file that's sitting on the workstation. So that might be our piece of audio, it might be our piece of video, it might be something that's got both in it, as in this case. And then that can refer back to say, actually, this file came from this tape that was recorded on this day from this machine. So we've got a full record inside the MXF file, which tells us the full history of where any piece of media came from, in principle. Now, not everybody puts that in. Not everybody puts that in, but all the facilities are there, and they are often in there. So there's lots of data that you can pick apart from an MXF file when it's not working, so that you can work out the history of what's happened. There's enormous complexity, and I'm skipping over how you can make different tracks, the different standards for making tracks in different orders, and greater complexity. I'm deliberately sticking with the level of complexity that you need to do delivery to a broadcaster. The bit of jargon for that is an OP1A, Operational Pattern 1A. It can go up to 3C, and some of you, those of you that have studied MXF on the train on the way home or whatever, may have seen a diagram, 9x9, a 3x3 diagram with 9 slots in it, describing the OPs. But really, OP1A is the one that you need to focus on. Almost all the equipment that's available on the market at the moment only uses that simple pattern. The key feature of OP1A is that you can have one audio, one video, one set of channels referring to one source object. Really as simple, almost as simple as it gets. And the next, please. The key features of MXF as compared with some other formats. MXF can wrap any Essence format, and I literally mean any Essence format. We've done software for one customer wrapping radar images, for example. So you can actually wrap any format. There is a set of standards for wrapping well-known formats so that everybody can read them again. And there's a lot of SMPTE documents that specify what we call the mapping, say the mapping of MPEG into an MXF file, the mapping of DV into an MXF file. And so that if you use the well-known formats, then anybody knows how to read it and how you've mapped it and where to find each frame boundary. But you can wrap literally any format that you like. You can also index any format, and by indexing I mean write a table so that you can immediately go to any frame boundary. You don't need to read a whole file to find 10 minutes in. You can just read the index and go straight to the 10-minute in point. Another feature is that you can read the metadata without reading the whole file again. You only need to read either the front or the back of the file to get all the metadata out and all the information that you need. You can add your own metadata schemes. Again, we do a lot of work on that. So the standards so that you can write what we call dark metadata in the jargon. Dark metadata if the reader can't understand it. So that you can put your own information into a file that is guaranteed a standard file, and any decoder should know how to skip over your own the dark metadata, the stuff that it doesn't understand. and that's extremely useful. Two other things that are sort of quite important for the broadcast industry. You can read a file while it's still being written, which you can't with most formats. You do need to do a little bit as you're writing it to make sure that that happens. It's possible to write MXF files that you can't read while they're being written, but many you can. And one of the features of AS11, which I'll come on to in a minute, is that the broadcaster in principle can start to play the file out before they've got the whole file. The other thing that's very useful when you come to troubleshooting is that any well-behaved application that uses MXF files should put its own audit trail in the file so that you can see who messed it up. If you had a file that was good, somebody adds some metadata to it, it stops working, you can see which applications messed it up. Application specification. So we've talked a bit about MXF, and the big problem with MXF is, as I say, it covers such a wide gamut of options, so that it can be used in many places. But in many applications, you want to restrict that so that you know that the receiver can read the file. And so the Advanced Media Workflow organization started writing application specifications, and application specifications start to constrain the options that a manufacturer may choose when they're writing a file. The principle of MXF is that you can always constrain down, so that you can say, I will only read AS11 files, and you know then that you only read AS11 files. It's still an MXF reader, coder, decoder, wrapper, unwrapper, but you can constrain. An MXF application specification is a set of constraints on MXF for various purposes. As you may guess, there's at least 11 of them. In fact, 12 is the last one that's published. Having said that, 7, 8, and 9 have never been published. But it may put in some constraints on those sort of things. So it may say, I will only accept AVC 100, or I will only accept MPEG up to 50 megabits a second. A set of useful operational constraints. If you're sending somebody a file and they've only got bandwidth to handle 50 megabits per second, then they really don't want to be sent something that's 100 megabits per second. And then you've got a handle that you can say, this is an ASO3 file for many of the American broadcasters, for example. And then, of course, then that gives you a whole load of specifications you can use to start to use for compatibility. Once you've got an AS in your hand. And actually have something to test against, rather than a very large set of possibilities. There's then, within each AS, there's a concept of a shim, which is again closing it down a bit more. So AS11 was written by the international community for high quality delivery. It was fired off by the UK community. But then the DPP have made a narrower shim that constrains some of the possibilities. So the AS11 standard, for example, allows anything up to 100 megabits. The DPP say we will only accept AVC 100 in the DPP shim, and we will only accept the metadata schema that we specify, and that will be the DPP shim within AS11 in the jargon. So AS11, there we go. Video at 100 megabits per second also allows SD, IMX, which we're all familiar with, HD, AVC 100, and they were AVC 100 with constant frame sizes so that you can edit it more easily. OP1A, which we talked about, up to 64 audio channels. Oh joy, they've got their own metadata scheme, and captions will be shortly the EBU STL for the DPP. So there we go. So that was AS11. This is the shim, how the DPP have closed it down. So there should be nothing in there that is really frightening to deliver. AVC 100, there'll be plenty of equipment around that can make AVC 100 files. They've chosen, the problem with AVC 100 is that it's a fairly chunky format. It takes a lot of computing power to play and record and to code. The thinking from DPP is that in 2 years' time, old Moore's law will have made that relatively straightforward. And I've got some sympathy with that point of view. Audio, 48K, 24-bit, nothing contentious there. Files must have space to add metadata later, which is an intelligent thing to do. You can leave space in an MXF file up the top of a file so that you can write more metadata later. Some of the manufacturers aren't doing that yet. There was a lot of time spent in a lot of committee rooms designing the format so that you could do that, and now nobody does it. But up till now, MXF has been used mainly just as a wrapper, and I mean, it could be QuickTime. Now we see more stuff going on that's more broadcast-centric. That will need to be done. They're asking for an XML file as well that's got exactly the same metadata in it as the MXF file. That will be useful in the early days before some of the applications can read the data out of the MXF file. STL subtitles, so they constrained it to not use the American subtitle standards, and certain constraints on the timecode. There are many ways of putting timecode into an MXF file. It's probably the most problematic bit of different MXF implementation, because every engineer's got a different view about how you write, how to handle timecode. So I just thought I'd give you 2 minutes on the sort of thing you look at when your MXF file isn't working. That's a sort of pattern to think about when you're trying to diagnose why an MXF transfer isn't working. First of all, have I received the file intact? Have I got the whole file? Is it the right length? Often it is, and occasionally it isn't. And people go further down it without understanding that the file was never any good in the first place. So the first thing to look at is the structural metadata. That's the metadata that's saying, this is how the media objects are laid out. This is the tracks that we've got. This is the video file. And if you can't understand that structural metadata, then it's game over. Now do we know how to deal with that structure? We can understand what's in there, and everybody should be able to get to that second phase. And it may be that once you've got the file in, you can't read the next bit because it's AVC 100 and you haven't got an AVC 100 decoder, or because it's got 64 audio tracks and your system only handles up to 16 or 2 or whatever. The next trick is, are we able to separate out the essence? Is it compatible with us? And then think about the descriptive metadata, what the program number is, what the title is, what the name of each tape was, that sort of stuff. And if you think about it logically and break it down in that way, it's relatively easy to find out what's going wrong with the MXF file. If you try and look at it as a whole object, then it's really quite hard. So, sources of disruption in transfer, structure of the file, has it been put together correctly? So has it arrived correctly? There's an internal structure to the file with blocks of data, KLV in the jargon, key length and value. So each block of data has got a key on the front of it that says, 16-byte key says, this is a media object, this is a frame of essence, and then it's got a length to say how long it is. So that immediately tells you almost always whether the file's corrupted or not. You can check through that, or software can check through that, and you can be pretty confident if that's complete, that your file hasn't been corrupted. And then, as we said in the last slide, check the semantics of the file. Can you understand what it's saying, what the metadata is saying? Is it semantically correct? Then check the contents, and then finally check the essence. And if you do it in that order, you'll be away. So a few last thoughts on delivering MXF files. The first one is, the whole point of doing this is to enable automation. The first step in this, in my view, is that we'll be able to minimize the amount of retyping that has to be done through the system, or writing out on recording report forms, or misreading what's written, what the last person didn't write properly on the recording report form, and so on. You're all familiar with that. So that should reduce costs on both sides. Costs on the receiving side because the metadata comes in correctly, costs and the file comes in correctly, costs on the sending side because you don't have to resend and have stuff come back to you because somebody's misread or you've made the mistakes on the wrong type of tape. And in my view, we'll then move on to another step forward that will have automation reading the metadata and making decisions on workflows. So that when we're starting to see this with Content Agent, when stuff comes in, you can set up workflows so that automation knows what to do with material, and stuff happens faster and quicker and with more warnings and more checking than we're used to having. And hugely important to find, the earlier you find out when a problem happens, the easier it is to correct it, and the cheaper it is to correct it. But that means that test tools are still important. There will be errors, both human and machine, and software. So it's really important to have test tools. We're all used to having the oscilloscope and the signal generator in the workshop. You're going to have a slightly different set of test tools, but they're well worth having, and they'll save a lot of time, and they're cheaper than a Tektronix oscilloscope. The other thing that's worth remembering is that AS11 is new, and file delivery is new in this country, but there are plenty of other places, particularly in the States, where programs are being delivered by file quite successfully. I think that's my lot.